So last class we have discussed about 3 pulse rectifier. Okay, in 3 pulse rectifier, how many thyristor are connected? 3 thyristor, each phase connected with 1 thyristor. Okay, we have already discussed, we have derived some average and output voltage waveform, and for different firing angles, what is the continuous conduction? Alpha should be between 0 to 30 degree. If it is more than 30, means 30 to 150, it will have a discontinuous conduction mode. Okay, we have already discussed 3 pulse rectifier. Now let us have 6 pulse rectifier. So first, in first module, while discussing single phase rectifier, first we have seen 1 pulse rectifier, then 2 pulse rectifier, then now we have seen 3 pulse, now 6 pulse. So first of all, what is the necessity to increase the pulses? Anybody? Yeah, it will have more output voltage. Any other advantage? Okay. So let us have this discussion. What is the necessity of increasing the pulses? Okay. Okay. So these are the output voltages we got. This is for 1 pulse, that is single phase half wave rectifier. Okay. Next, single phase full wave rectifier. This is 2 pulse. So 2 pulses we are getting for 1 cycle. This is my 2 pi, right? Okay. So here we got 3 pulses per cycle. This is 3 phase half wave rectifier. Here we will get 6 pulses per cycle. Now what is the advantage is, now we are converting from AC to DC, right? We are converting from AC to DC. That is the use of rectifier. Okay. Now, so this is my AC signal. Okay. This is pi, this is 2 pi. This is omega t axis, this is the source voltage. Okay. If you are talking about single phase, this is my source voltage, this is AC signal. Now, if you want a ripple free constant DC, if you want a ripple free constant DC, how it looks like? If this is your 0 axis, at time 0 means it will have a constant value. It will have a constant value. For that purpose, to make pure DC, what we need to connect? At the output of a rectifier, we need to connect some arrangement, that is called filter. That is called filter. Okay. We have to make some extra arrangement to make ripple free pure DC. Now look at here. To make this, your filter size will be more. Okay. To make ripple free DC here, okay, your filter size will more, since we have no voltage during pi to 2 pi. We have no output voltage during pi to 2 pi. Similarly here, the amplitude of pulses is very high here. The amplitude of pulses is very high. It is going to Vm. It is going to Vm. So here also, to make pure DC, the size of filter will be high, but less than this. But less than this. Now come to here. Here the amplitude of pulses are less. Here the amplitude of pulses are less. The ripple content is less here as compared to this. As compared to this, the ripple content here is less. So here again the filter size will decrease, so on, and 6 pulse. 6 pulse is nearly equal to constant. 6 pulse is nearly equal to constant. Okay. So this is the main advantage. the filter size is going to be reduced at a high level if you will increase the number of pulses. Secondly, the power of the rectifier will increase. Power delivered to the load will increase. The 3-phase rectifier that give that much of power which cannot be given by a single phase, half wave or full wave rectifiers. Okay. Now these are something we have discussed about the advantage why we are going for 6 pulse converter. Okay. We have already discussed 3 pulse. Now let us go for the circuit diagram. Okay. So this is the circuit diagram. We have 6 thyristor here. We have 6 thyristor. In 3 pulse, how many thyristor we have? 3. So instead of this, now we have 6 thyristor. Upper one is T1, T3 and T5. Lower bridge is T4, T6 and T2. Okay. So here 2 valves are connected to each page. 2 valves are connected to each page. Okay. Now the upper part bridge is known as anode valves, that is your 1, 3, 5 means T1, T3, T5 are known as anode valves, and your T4, T6, T2 are known as cathode valves. T4, T6, T2 are known as cathode valves. Okay. Now the firing sequence is given by 6, 1, 1, 2, 2, 3. Okay. To understand this point, let us draw the phase waveform, 3-phase waveform. Then only we can understand this point, how the firing sequence came. Before going to the waveform, first you remember 2 thyristor will conduct at a time. 2 thyristor will conduct at a time, one from upper half, one from upper bridge and another from lower half. One from upper half, another from lower half. 2 thyristor will conduct at a time. 1 thyristor will conduct for 120 degree. 1 thyristor will conduct for 120 degree. How we will see? Why it is conducting for 120 degree? We will see that in waveform. Okay. 1 thyristor will conduct for 120 degree and each pair will conduct for 60 degree. 2 thyristor is conducting at a time. That 2 thyristor will conduct for 60 degree. Then it will shift to next pair. Okay. Now let us draw the 3-phase source voltage waveform. Yeah. So this is phase A, this is phase B and this is phase C. Each are apart by 120 degree. Okay. So it's a symmetrical 3-phase voltage waveform. Okay. Now let us distinguish some point. Okay. Already we have discussed at alpha equal to 0 means omega t is equal to how much in 3 pulse? 30 degree. So we cannot fire below 30 degree. We cannot fire below 30 degree since it is reverse biased by the already conducting thyristor. So let us start here from 30 degree. Let this point is P. At instant P, phase A is more positive than other phases and phase B is more negative than other phases. Already we have discussed in case of 3 pulse rectifier also. At instant P, you can see this. At instant P, phase A is the leading phase and phase B is the more negative phase. So the thyristor which is connected to phase A will conduct and the thyristor which will connected to phase B will conduct. Now from upper half one will conduct, from lower half one will conduct. So which is connected to positive here? Phase A. So T1 will conduct here. Okay. Phase A is more positive than other phases. Here we have 2 positive, right? One is phase C, another is phase A. But phase A is more positive than phase C. So thyristor T1 will conduct. From lower half, phase B is more negative, so thyristor T6 will conduct from phase B. If T1 and T6 will conduct, now the current will flow in this path A, T1, then your load, that is resistance and inductance RL, then T6 and back to B. This is the current flow of your phase A and phase B when it is conducting. When it is conducting, thyristor T1 and T6 are conducting. At that time, this is the direction of current flow. Okay, so 2 thyristor will conduct at a time. 2 thyristor will conduct at a time. Next, at point Q, you can see this point, at point Q, A is more positive than other phases. Look, phase A at this point means near about here. A is more positive than other phases and C is more negative than other phases. C is, now in negative we have 2, B and C. In positive we have 1. At instant Q, positive we have only 1 phase. Okay, but in negative we have 2 phases, phase B and phase C. But C is more negative than phase B. So which 2 will conduct? From phase A, 1 thyristor will conduct, and from phase C, 1 thyristor will conduct. Okay, now T1 is conducting. Previously it will continuous its conduction. Previously T1 is conducting, so it will continuous in conduction, and from phase C 1 will conduct. Phase C is connected to which thyristor? T2. Phase C is connected to which thyristor? T2. So T1 and T2 will conduct. T1 and T2 will conduct from instant Q. From instant Q. From P to Q, which thyristors are conducting? T1 and T6. T1 and T6 are conducting. At instant Q, T2 will start conduct and T6 will commutate. T2 will start conduct and T6 will commutate. Next, from Q, T1 and T2 will. So when T1 and T2 will conduct, so this is the direction of current flow. Your phase A, then T1, then resistance, inductance, T2 and back to phase C. Back to phase C. Okay. Any doubt till now? Any doubt till now? Okay. So next we will proceed further. At instant R, let us now next, at instant R, at this point, which is more positive? Phase B is more positive and phase C is more negative. In negative only we have 1. Okay. In positive we have 2. But A and B both are in positive, but phase B is more positive than phase C. So which 2 will conduct? T3 and T2, right. T3 and T2. From phase B, T3 will conduct. From phase C, T2 will conduct. Means T2 is already conducting. T2 is already conducting. From instant Q, it will continue its conduction. T2 will continue its conduction from R. From instant Q, T2 is conducting, T6 is commutated at instant Q. So T2 will continue its conduction from Q up to R, then beyond R also. So now the current will flow in this direction. B, T3, resistance, inductance, next T2 and back to C. Okay. This is all about, we are discussing the circuit operation, how the circuit operates. After that we will discuss the output voltage waveforms. Okay. Now next, at instant S. At this instant, which is more positive? Phase B is more positive, and which is more negative? Phase A is more negative. Phase A is more negative. Phase B is more positive. Okay. Means T3 will conduct here and T4 will conduct here. Okay. One will conduct from upper half, one will conduct from lower half. Which is connected to A? T4 is connected to A from lower half, right? So T3 and T4 will conduct during R to S. Okay. So T3 is already conducting, so it will continue its conduction beyond R, and T4 is fired at instant S. So the current will flow in this direction, B, T3, then resistance, inductance, T4 and back to A, back to A. Yeah, this is the direction of current flow. This is the direction of current flow. Next, at instance T. At instant T. Now tell me, which is more positive at instant T? Vc is more positive, which is more negative? Va is more negative. Va is more negative, Vc is more positive. Okay, so from upper half which will conduct, which is connected to C from upper half? T5. Okay, from upper half T5 is connected to C. Okay, and from lower half which will conduct? From lower half which is connected to A? T4. So T4 and T5 will conduct during this duration. Okay, so now the current will flow C, T5, R, L, T4 and back to A, and back to A. Okay, so this is the direction how current flows during this period, okay. Next, at instant U. Tell me, which is more positive at instant U? Vc is more positive. Okay, Vc is more positive means which is connected to positive valve? T5. T5 is connected to positive valve of phase C. Okay, then which is more negative? Vb is more negative. Vb is more negative. So which is connected to negative valve in phase B? T6. T6. Then, so during this instant, 5 and T5 and T6 will conduct. During this instant, T5 and T6 will conduct. So how the current will flow? From C, then T5, resistance, inductance and T6 back to B. Back to B. Okay. So this is all about the, just we have discussed how the conduction sequence came. Okay, how the conduction sequence came. Now we can write the conduction sequence 6 1, 1 2, 2 3, 3 4, 4 5 and 5 6. Okay, next will be again 6 1 and it will be repeated. It will be repeated. We can see here each duration, total duration is how much? One cycle input. One input cycle duration 360 degree, right? So 360 degree. How many sequence we have? 6. So each will be 60 degree. Each duration will be 60 degree. Now in two duration, one thyristor is always overlapped. Here 2 is overlapped, here 3 is overlapped, here 4 is overlapped and here 5 is overlapped. Okay, means one thyristor will conduct for how much duration? 60 plus 60. So 120 degree. One thyristor will conduct for 120 degree. Each pair will conduct for 60 degree. Each pair will conduct for 60 degree. Okay, so during one pair we will get one pulse. During another pair we will get another pulse. Like that we will get 6 pulses per one cycle. Like that we will get 6 pulses per one cycle. Okay. Now, so this is the conduction sequence. How it came, how the conduction sequence is, we have already discussed here during more positive and more negative of phases. Because of the more positive and more negative of the phases, this conduction sequence came. This is nothing but the natural crossover of 3-phase source voltage waveform. The natural crossover of 3-phase source voltage waveform. Okay. Yeah. Next, let us see the output voltage. During each instant, how the output voltage will be. Okay. This is my source voltage, input voltage. This is phase A, phase B and phase C. These are the gate pulses to different thyristor. This is gate pulse to T1, then T2, T3 and so on. Now we have to discuss one point. In case of 3-pulse converter, your output voltage is nothing but your phase voltages. Here, phase voltages. But here we have a bit different. Here we have bit different. What is the difference? Let us discuss this point. For this, let us draw the circuit diagram again. So this is my circuit diagram. Okay, these are the upper half and these are the lower halves. T1, T3, T5, T4, T6 and T2. Okay. Now, when one pair is conducting, let us assume first which pair? 6 and 1. 6 and 1. First let us assume 6 and 1 is conducting. So when T6 here and T1 here. Okay, then which phase are excited? Which phases are excited? VA and which phase? VB. Okay, from lower half T6 is connected to phase B, from upper half T1 is connected to phase A. Okay, so VA, VB is excited. Now, what is the output voltage? What's the output voltage is? It will follow the line voltage. Since two phases are excited here, it will follow the line voltage VAB. VAB. What happened in 3-pulse rectifier? Only one thyristor is excited at a time, right? Only one thyristor is excited at a time. So only one phase is excited. Only one phase is excited at that time. So other remaining two phases are isolated. In case of 3-pulse rectifier. But here in case of 6-pulse rectifier, two phases are excited, one phase is isolated. Two phases are excited and one phase is isolated. So the output voltage will follow the line voltage, not the phase voltage. The output voltage will follow line voltage. Let us now discuss for next sequence. What is the next sequence? 1 and 2. So when 1 and 2 will conduct, which one will conduct? So VA is excited. Then for 2, VC is excited. VC is excited. Now the output voltage will follow which waveform? Which line voltage? VAC. VAC. Next for 2, 3. Okay. Next for 2, 3. For 2, 3. 3 means upper half. Upper half means B. Then VC. So the line voltage will follow. Output voltage will follow the line voltage VBC. VBC. Next 3, 4. Okay. 3, 4. So T3 is connected to phase B, T4 is connected to phase A. So it will follow VBA. Okay. Similarly, next 4, 5. So which phases for 4, 5? 5 upper phase means VC and 4 VA. So output voltage will follow the line voltage of VCA. Okay. Next 5, 6. For 5, 6 VC and for 6 VA. B. So the output voltage will follow the line voltage of VCB. VCB. So that's the difference between 3 pulse rectifier and 6 pulse rectifier. Here the output voltage will follow different line voltages for different conduction, for different duration. There it will follow the phase voltage. There it will follow the phase voltage. Now that's why we have drawn here line voltages to draw the output voltage instead of phase voltage. Okay. Okay. So let us draw for alpha equal to 0, means there is no delay. There is no delay. Okay. So first, which two we have taken? 6 and 1. 6 and 1. So during 6 and 1, it will follow VAB. Okay. Now this is my VAB. This is my VAB. It is given gate pulse here at this instant and it will start conducting from here at this instant. Okay. It will start conducting from here up to what degree, how much degree it will continue its conduction? Up to how much degree one pair will continue its conduction? 60 degree. Okay. So it will start its conduction from here to here. Okay. So it will end its conduction here. Is it clear? Is it clear? Yes, sir. So for next, what is the next pair after 6 1? 1 2. Okay. 1 2. So it will follow my VAC. Okay. After this it will start conduction from here and it will continue its conduction up to here, next 60 degree. So similarly, next 60 degree VBC, then VBA, then VCA, CB, then AB, then AC and BC, it will continue its conduction and so on. Okay. So this is the output voltage we will get. This is the output voltage we will get for alpha equal to 0. For alpha equal to 0. Okay. Now I want one point from you. So what is the relation between phase voltage? To derive the output voltage, we need to know the relation between phase voltage and line voltage. Okay. So tell me, VL equal to root 3 V phase. So what is the difference in angle? Your line voltage will lead by how much degree to phase voltage? 30 degree. Okay. Line voltage will lead by 30 degree to phase voltage. We have to remember this point to derive the output voltage for alpha equal to 0. For alpha equal to 0. Okay. Now let us write the equation for different phases. VAN is equal to how much? VM sin omega t. VBN, VM sin omega t plus okay. Okay. There must be 120 degree phase difference. There must be 120 degree phase difference. Similarly, if I will write VAB, so it is VAN minus VBN. For writing VAB, this is VAN minus VBN. So if this is the function of VA, so I can write here root 3 VM sin omega t plus pi by 6. Just you told me this is the relation VPH. Okay. So root 3 into phase voltage. This is my phase voltage. Root 3 times phase voltage. It will lead by 30 degree. So plus pi by 6. Okay. Now let us found the output voltage. Now tell me from where to where I will integrate. Alpha plus 60 degree to alpha plus 120 degree. One pair will conduct for how much duration? 60 degree. So if I will start from 60 degree, alpha plus 62, alpha plus 120 Vm sin omega t d omega t. Vm sin omega t d omega t. Okay. If you will take phase voltage, this is the expression. If you will take line voltage, then alpha plus 62, alpha plus 90 degree root 3 Vm sin omega t plus pi by 6 d omega t. Okay. If you will take line voltage, this omega t will reduce 30 degree because already we have ahead. We are ahead of 30 degree because we have taken here in function 30 degree plus. So we have to reduce here at omega t axis 30 degree. So here we will reduce 30, here we will reduce 30. So it is 30 to 90. If you will take phase voltage 60 to 120. If you will derive both, the answers will be same. There will be no change in the output voltage. Okay. There will be no change in the output voltage. This will give you and this will give you, both are same answer. Both are same answer. But convenient to take this. Since our output voltage is a line voltage, we are not following phase voltage. We are not following phase voltage. Every case my output is line voltage. So it is convenient to take this expression rather than this. It's convenient to take line voltage. Okay. So let us now go for next firing angles. So these are the gate pulse given to different thyristors. So let us draw the line voltage again. Now alpha equal to 30. Alpha equal to 30 means omega t equal to how much? 60 plus 30 is equal to 90 degree. For 6 pulse converter, alpha equal to 0 means omega t equal to 60 degree. Since it is line voltage. Since it is line voltage, alpha equal to 0 means omega t equal to 60. So here, if alpha equal to 30 means omega t is equal to 90 degree. So T1 will be fired at omega t equal to 90. Here is my 90 degree, right? Here is my 90 degree. So T1 will be fired at omega t equal to 90. So how the waveform will be? It will, at 90 degree it will follow my VAB. At 90, this is the VAB line voltage. So at 90 degree it will follow VAB. Next VAC, then VBC, BA, and it will continue its conduction, so on. Okay. So this is the waveform for alpha equal to 30 degree. Alpha equal to 30 degree. Okay. Next we will see for different values of alpha how the waveform will be. Now alpha equal to 60 means omega t is equal to how much? Omega t definitely it is 120 degree. So here is my 120 degree. I will start my conduction. I will fire my thyristor T1 from this instant. I will fire my thyristor T1 at this instant 120 degree. Okay. So from this instant it will follow VAB. From this instant it will follow VAB. So this one is my VAB, right? This one is my VAB. So from here the output voltage will start. Okay. Now this is following VAB from this instant. Okay. From here output voltage starts. So as we go on increasing alpha, the output voltage is going to decrease. The output voltage is going to decrease. Okay. So this is VAB, VAC, then so on so far. Okay. Next, let us see the output voltage for alpha equal to 90 degree. Alpha equal to 90 degree. Okay. Now alpha equal to 90 means omega t equal to how much? 150 degree. Okay. Alpha equal to 90 means omega t equal to 150 means here. Okay. This is my 150 degree, right? So here I will fire my thyristor T1. Here I will fire my thyristor T1. So it will follow VAB after this instant. Okay. So it will follow, this is my VAB. Here it is, this is my VAB. So it will follow my VAB after this instant and it will continue its conduction to negative direction since we have taken as inductive load. Since we have taken as inductive load, so it will continue its conduction to negative direction. But we can see the positive interval and the negative interval both are same. The positive interval and the negative interval both are same. Okay. We can see here both intervals are same. So the output voltage will be 0 during this firing angle 90 degree. During this firing angle 90 degree, the output voltage will 0. Okay. So just we will see while we will derive the output voltage wave equation, then we can validate this. At firing angle at 90, at alpha equal to 90 degree, what should be the output voltage? Okay. Next we will see for 150 degree, alpha equal to 150. So alpha equal to 150 means omega t is equal to, omega t is equal to 210. Okay. So where is my 210? This is 180 plus this is 30. So here is my 210. Okay. This is 180, right? This is 180 plus 30. So here is my 210. So from this point it will follow VAB. So here is my VAB. So from here it will start its conduction. Okay. So from here it will start its conduction. This is VAB. Then it will follow the next one and next one. Okay. So now I am getting negative output voltage. Now the average output voltage is negative. When the alpha is beyond 90 degree, I am getting negative output voltage. Now the rectifier is operating in which mode? Inverting mode. Now the rectifier is operating in inverting mode and the power is feedback to the source. Power is feedback to the source when it is beyond 90 degree. Is it clear, the waveforms, or any doubt? Is it clear? Okay. Now so these are the corresponding line voltage, already we have discussed. Okay. These are the phase voltages and these are the line voltages. So the average output voltage, okay. So if you will take up to pi, so how many pulses you are getting up to pi? 3 pulses. Either you can take the average up to pi or you can take up to 2 pi, no problem, both are same. Why? Because the average if you will do divided by pi by 3 or divided by 2 pi by 6. Divided, if you will take the cycle up to 2 pi, you are getting how many pulses per 2 pi? 6 pulses. So again you will get pi by 3 only. So better to take up to pi. Okay, better to take up to pi. So just integrate this and let me know how much you are getting. Alpha plus 30 to alpha plus 90 degree. Alpha plus 30. If it will start from, if I am taking line voltage here as a function, so I will start from 30 degree. If I will take phase voltage as my function, I will start from 60 degree. I will start from 60 degree. So better to take line voltage since our output voltage is line voltage, not phase one. But in both cases you are getting same result. You can verify your answer. In both cases you will get same result. Okay. So just derive this. So your output voltage is equal to 3 by pi integration from alpha plus 30 to alpha plus 90 degree root 3 Vm sin omega t plus 30. Okay. D omega t. This is my function. Pi by 6 means how much? 30 degree, right? Okay. So just take out common. So 3 root 3 Vm by pi alpha plus 32 alpha plus 90 sin omega t plus 30 d omega t. So this will give you, so if you do the integration, minus cos omega t plus 30, limits will be alpha plus 30 to alpha plus 90. So take this minus sign outside, 3 root 3 Vm by pi, just put the limits, cos, so in place of omega t we need to put the limit, alpha plus 90 degree plus 30 degree minus cos alpha plus 30 degree plus 30 degree. Okay. So minus 3 root 3 Vm by pi. So here cos 90 plus 30 how much? 120. Alpha plus 120 minus cos alpha plus 60. Okay. So just open these brackets. Minus 3 root 3 by pi into Vm cos A plus B. So cos A cos B minus sin A sin B. So minus is here, cos alpha cos 60 plus sin alpha sin 60. Okay. Now put these values, minus 3 root 3 by pi into Vm cos alpha, what is the value of cos 120? Minus 1 by 2 minus sin alpha sin 120 root 3 by 2. Okay. Next, minus cos alpha cos 60, how much it is? 1 by 2, then plus sin alpha sin 60, how much? Root 3 by 2. So here it is going to be cancelled, this is plus, this is minus. So finally 3 root 3 by pi into Vm, so here we will get minus 2 into cos alpha by 2. So this will going to cancel, this minus minus will be plus, so it will be 3 root 3 Vm by pi cos alpha. So this output voltage is 3 root 3 Vm by pi cos alpha. So just we can see, in case of 3 pulse rectifier, the output voltage was 3 root 3 Vm by 2 pi cos alpha. So just compare these two. Here my output voltage is doubled. Here my output voltage is doubled in case of 6 pulse rectifier. In case of 3 pulse rectifier, it is half of 6 pulse rectifier. Now in terms of line voltage, we can write this equation further. So V0 is equal to, so since we know root 3 Vm is equal to root 2 VL, okay, where VL is the line voltage. So here we can write 3 root 2 VL by pi cos alpha. Just simplify this term and let me know how much it is. 3 root 2 by pi. 3 root 2 by pi, how much it is? (1.35 VL cos alpha). This is the final expression of output voltage of 6 pulse rectifier in terms of line voltage. This is in terms of maximum phase voltage. This is in terms of line voltage. The output voltage is 1.35 VL cos alpha. Okay. Similarly, we can find out the RMS output voltage. Okay. So just do the integration for RMS output voltage and let me know how much you are getting. For RMS output voltage, over? Okay. So this is the answer you are supposed to get in terms of line voltage. Okay, just put root 3 Vm equal to root 2 VL. This is the relation, root 3 Vm equal to root 2 VL. So this is the answer you are supposed to get. VL under root 1 plus 3 root 3 by 2 pi cos 2 alpha. Cos 2 alpha. Okay. So this is all about your 6 pulse rectifier. We have discussed the conduction sequence. Okay. How the conduction sequence is? How the conduction, it depends upon which factor? Natural crossover of source voltage. Natural crossover of source voltage. Okay. This depends upon the conduction sequence. It's natural crossover of source voltage. The conduction sequence is what? 6 1, 1 2, 2 3 and so on. Okay. Next, for different firing angles, we have seen the output voltages and we have derived the output and average RMS voltages successfully. So, thank you.